The trachea is a sophisticated, complex structure. Each small component gives rise to a valuable function in the respiratory system. The trachea begins at the caudal border of the larynx, at the laryngeal cartilage, and terminates at the carina, where the trachea bifurcates into two primary bronchi. The respiratory epithelium lines most of the respiratory tract. However, there are some specializations in the trachea. The trachea has an unusually thick basement membrane that underlies the respiratory epithelium. In the deeper layers of the tracheal wall, layers of seromucous glands are present in the submucosa. Incomplete C-shaped hyaline cartilages support the tracheal wall, keeping it open under high pressure during breathing. In the intercartilage gap lies the trachealis, providing flexibility. This is useful during swallowing, so the trachea can partially collapse whilst food passes through the esophagus on the dorsal side. The innermost layer of the trachea is lined with respiratory epithelium. This heterogeneous layer is mainly made up of both ciliated pseudostratified columnar cells, goblet cells, and a layer of basal cells that lie below. Basal cells are thought to be cell replacement mechanism in the epithelium. Studies have shown that basal cells are precursors for ciliated pseudostratified columnar cells or ciliated cells. Whilst the respiratory epithelium provides protection for the layers below, the main function of this layer is to act as an air conditioning unit for the lungs. The cells now shown in green are the ciliated cells. Ciliated cells outnumber goblet cells by 5 to 1. Each ciliated cell has roughly 200 to 300 cilia projecting into the respiratory lumen. Tight gap junctions between each ciliated cell and the basement membrane below create an impermeable barrier to protect the deeper layers. The main function of these ciliated cells is to move mucus up and out of the trachea to the larynx, opposing gravity, to be eventually ingested. This prevents mucus from reaching the lungs, thus causing a fatal blockage. The cilia beat in a rhythmic pattern to move mucus out of the trachea effectively. The cells now shown in pale green are the goblet cells. Much like the ciliated cells, the goblet cells provide a vital function for air conditioning. The goblet cells account for approximately 20% of the respiratory epithelium. The small spherical objects inside the goblet cells are the secretory vesicles. Through exocytosis, these electron-loosened vesicles expel mucin when released into the lumen, where it becomes hydrated to become mucus. The mucus released by the goblet cells has two functions: to trap inhaled foreign particles and to provide moisture to the incoming air to prepare for gaseous exchange.